Greetings. This is Ham Radio GMRS Test and Review. My name is Dave. My call sign is November 8 Delta Alpha Victor. The motto for my channel is one test is worth 1,000 expert opinions. Today, we're going to be talking power supplies again. Now, I know recently I went through a video where I showed you what power supply I was using and why I decided to replace it with a better power supply that had a more stable voltage supply than the one that I was using. I did that because we have very expensive radios, and you really don't want to have a power supply that's going to drop voltage every time you transmit. So a lot of people, my subscribers, have asked me about these power supplies that are really cheap on eBay. They are computer power supplies from HP. All right, so this is what one of them actually might look like. All right, they've got the long connector here at the end, got a little fan here, and the place to plug in your power cord right here. And these fit inside the computer very nicely, and they provided all the power necessary for the computer to operate completely. The problem is that these power supplies don't put out the amount of voltage that we require. They have the amperage and the wattage, but they don't have the voltage that we require. All right, reading on the label that is on here, first of all, there's a part number that if you decide that you want to use one of these power supplies, you're going to need. Now, the part number for this particular one, it doesn't actually say part number. What people are going by is the regulatory model number, which in this case, this is a HSTNS-PL14. All right. And if you go and you search on YouTube for that part number, you will find videos on how to modify this particular power supply to work in our ham shack. Now, the reason why I don't recommend this just as is in our ham shack is that the output is only 12 volts at 38.3 amps maximum, or a maximum of 460 watts total. Now, while the amperage is great, that's a huge amperage, the voltage is not correct. Now, even though it says 12 volts, and a lot of our stuff will run on 12 volts, hopefully, a lot of it is rated for a 12.6 volt minimum. And a lot of them will also go up to around 15 volts maximum. Most power supplies run at 13.8, 13.9, and some people like to crank their voltage up to 14.4, 14.5. Now, I haven't done this myself because my new Astron power supply, the voltage doesn't drop when my radios transmit. It stays very, very stable. So I don't see any reason to up the voltage to 14.4 or 14.5 volts. However, I can do it. The power supply is adjustable for that. But the problem with these, of course, is the lower voltage. And they have the amperage and the wattage that you need, but not the voltage. So what I found on the internet after I looked up that regulatory model number, as I explained to you, is I found that there are videos that show how to modify these things in order to be able to have a variable power source and have 13.8 to, let's say, 15 volts available to you. And you can do that. It's a very easy modification. If you're not afraid of soldering, then it's very, very simple. Let me explain to you about these power supplies, though. The voltage does not stay rock solid like I believe should be for a nice expensive radio, where you're going from maybe a couple of amps on receive up to 20 amps immediately on transmit. The voltage will drop with these. However, even though I don't recommend them for powering your radios, they are perfectly fine for powering low power radios, like a VHF UHF radio with, let's say, maybe 15, 20 watt output, and and also your HTs. So I used HTs for base units for many months, so about a year actually. And even though I had good success with them, I decided, of course, to move to bigger and better radios. So you can use a power supply like this, but what I suggest is that you use it as a bench supply, meaning that it's not your main source of power, that you get a good power supply for your big radios. And you use this radio to power your accessories, and you can use it to connect USB-A, USB-C charging outlets, and so you can use it to charge all your batteries and things like that. So this is just a general purpose power supply. Now, the power supply I showed you before, I had not modified yet. This one is the exact same model, but this one I've actually modified. Now, the modification is very simple. If you go through YouTube and you look up that number that I explained to you, what you want to do actually, and let me start a little bit from the beginning, is you want to go out to eBay and buy one of these things, or maybe two. At the time that I was looking to buy one, they were between $5 and $8 a piece, which is just tremendously cheap. And it makes for a really great project if you're not afraid of soldering, as I said. So I didn't actually buy a couple of them. I told a friend I was going to buy them, and he said, hey, I got a bunch of them. Let me send you a couple. So a very good friend of mine, Red from Red's Engineering, sent me a couple of these things. And so what I've done is I've watched the video, and I got all the parts that I needed. And the parts that you need basically are just 3 different resistors. If you want to do it the same way I did, only 2 are required. And a way to actually tap into the connector here on the bottom to be where you actually have your wires coming off of it for your power. This side here is your positive, and this side here is your negative. So what I did is I decided to get a full-length bus connector, and what I did was I said, okay, I cut off what I didn't need over here on this side. And if you see a black line down there, that's where the split between positive and negative is on this little connector here. You can actually see on the back here, there's a little line where the positive and negative are. So then I took this bus and I soldered a couple of wires here on the back, and then on the other end, I put power poles because I've standardized on power poles on my entire shack. So now, if I need to power something, plug this onto the connector here. And of course, my fingers are not working today. Plug this in, and I have 14.4 volts at about 30 amps, and maybe a little bit more than that, maybe about 35 amps. And I can power just about anything and everything, including a radio if I really wanted to, on my desk. So, what did I have to do to modify this radio? First thing I had to do is you have to take the cover off, and you'll find that there are 2 different very small circuit boards in here. There's one on this side on the back, and there's one on this side in the back. And each one requires a resistor to be soldered to it. And that's it. So you solder a resistor on the circuit board on this side, circuit board on this side. What you need to do at that point is that there's a little potentiometer over here on the circuit board here on this side, and you take your plastic screwdriver, not a metal screwdriver, and you put your volt ohm meter on here, and you just turn that potentiometer until you get to the voltage that you want, and then it's set. I turn mine up, like I said, 14.4 volts. I put the covers all back on here, and there's 2 more things that you can do. There's actually, I did 2 of those things. You only need to do 1. So what you need to do is there's a little LED, a little green LED right here. I wanted it to come on when I plugged it in. So there's another resistor, a third resistor, that you solder across this board here. All right, that will power the LED when you plug it in. And the other thing to do is this jumper here, right? This little red jumper here that I put. Now that jumper is basically the on switch. So it's on permanently at all times. But if I want to add an on-off switch, all I have to do is cut it and put the switch in line with this jumper, and then I can use that to turn this on and off and leave it plugged in at all times. Now, that's it. That's the total amount of modification done. The whole thing took me about an hour to do the two resistors, this third resistor and this jumper, maybe an hour and 15 minutes. I didn't know what I was doing. I'm not a great solder guy, but I did it. And like I said, it was about an hour and 15-minute project. And then it took me a little while to figure out to use this bus. And so, I soldered that and put the cable together. I think all told, I have about 2 hours. And it was a fun project. I mean, it was really a lot of fun. So when I plugged it in, and it comes right up and you get 14.4 volts. But the voltage, if you put a load on it, all of a sudden volts drop down a little bit. Not a lot, probably not enough to damage anything, but you know what? I don't want to do that. So, again, this is a good bench power supply. It'll power just about anything that you're going to need it to, but I wouldn't power my big expensive radios off of it, okay? And that's really all there is to these cheap HP computer power supplies that you can find on eBay. Very, very cheap. I don't know what they're going for today, maybe about 15, 20 bucks, even though that's pretty cheap. Like I said, at some point, these were $5 to $8. And and a friend of mine, like I said, sent them to me. So this could be a really fun project for you. You can build a power supply for you. You can build one for your bud. You can do just about anything you want. So if you would like to find out more, please post questions in the comments. I'll be happy to answer them to the best of my abilities. I will put links to some things that I used on this project, because I did use a little bit of heat shrink tubing. So anyway, this is Dave with Ham Radio GMRS Test and Review saying 73 and so long.